64 years old male patient and suffer from chest pain for 1 month. Risk factors hypertension for 14 years. And the echo show us left ventricular diastolic dimension is 60 millimeter. This is laboratory data. And you can see glucose and NT-proBNP a little bit higher. And TNI this time is very high. ECG show us elevated ST segment in leads V1 to V3. Depressed ST segment in leads 1 IVL and V5, V6. And you can see negative T wave in leads 1 IVL and from V3 to V6. This is the angiography on the June 6th at the local hospital. And from the imaging, you can see very long diffuse stenosis from the middle to distal circumflex. And the diameter of circumflex is very small. And from this imaging, you can see from the distal to the middle, left anterior descending, there are very serious stenosis with severe calcification. There are a stenosis at the distal left anterior descending. This is a right coronary artery imaging, almost normal. At the there are middle stenosis, mild stenosis at the proximal to the middle. There is a contralateral flow to support the distal left anterior descending from the right coronary artery.
For this patient is a high risk patient. This is the angiography today. We can see in the proximal OM and the distal LCS there is serious stenosis. We can see severe stenosis and calcification in the proximal LAD. So his lesion is complex. The distal LAD vessel size is too small. It is not fit to CBG. Based the examination results for this patient, we will plan to perform intravascular imaging guided PCI on LAD. We will use IVAS to assess the type and the severity of calcification of LAD.
And we can see this is a triple vessel disease, the distal RCA, PDA, PLV, and the diffuse, the lung severe stenosis with calcification in LAD and circumflex. So this is a typical CHIP patient. So like Professor Zhao indicated that the left ventricular support system, for example, in this patient, we implanted the IABP before we touched the patient, which is relatively very important. And after the initiation of the IBP, we can see that the blood pressure, the heart rate of the patient all get better.
The distal LAD is too small. We use a 10 balloon to inflate the distal LAD. We use a 105 millimeter balloon to inflate the proximal LAD. This is a severe stenosis. Then we use IVAS to assess the type of the calcification in the proximal LAD.
I think that, Dr. Zhao Ji indicated, that we touched LAD first because this is our target vessel for today. There are several indications for this patient. One thing is that we know the left ventricular function for this patient is not so good. The EF, value is 36. And also ECG and the ultrasound also indicated that the anterior wall of the patient suffered old myocardial infarction before several times. So I think that the recanalization for LAD is of key importance for this patient. Not only just recover the left ventricular function, but also it's a good prognosis for the patient. So like Dr. Zhao Ji indicated, after a 1.0 balloon predilation, we use IVAS to check the plaque burden distribution as well as the calcification of the LAD lesion. And also, I think that one key information in this case is that this kind of IVAS system is a 100% domestic, which means that this kind of a machine and also the software is made in China. So we can see this is a pullback from the mid-distal LVD to the proximal part. And we can see this is a 60 megahertz, IVUS image with over 100 frame per second. So this is a relatively very clear. The imaging is not so much blurred like what we see from the 45 megahertz imaging catheter of IVUS before. We can see that there is relatively a lot of concentric fibrotic with a superficial calcification, very high plaque burden with a lot of, we can see, attenuated plaque. So I think that what Professor Zhao has stated is quite a wise and a very good demonstration for relatively high-risk CHIP patient like this one. We can see the patient suffer diabetes mellitus, hypertension, and we detect a lot of supracalcification with attenuated plaque. This is a relatively high predictor for the slow flow and non-flow phenomenon. So we can see that Professor Zhao didn't use very large balloon to make a predilation at high pressure. I think that this is a key information to guarantee the good prognosis. So we can see that there is a lot of superficial calcification, especially as a most severe part. We can see there is some attenuated plaque underneath the superficial calcification. And also we can see there is something over 270 degrees of superficial calcification. However, one thing should be noticed that although the calcification angle is relatively large, I think, majority of the audience should agree that this is a circumferential calcification. But we can see the diameter of the vessel is relatively also large. This is a, how to say, for me, this is a pain spot in this patient because if we use rota for this patient, I think that a 2-millimeter burr doesn't touch the wall very well. However, on a 5.3 millimeter square for the proximate LVD doesn't meet the cutoff value for the good prognosis. So I think for this kind of current situation, I don't think rota is going to play a great role in this patient. So how to treat this kind of relatively large angle superficial with a circumferential calcification is a good question. Let's going to see the rest of the pullback from the LVD. We can see a long diffused eccentric fibrotic with a superficial calcification plaque burden. This is a high plaque burden. And also as a proximal part of the LVD, we can see some clear landing zone. So this is a good information because maybe the proximal part of the LVD will have some good landing zone. We do not worry too much if the stent need to be protruded into the left main or not. So this is the pullback from the proximal part of the LVD. Professor Zhao, what do you think next step? What should we do to treat the calcification we detect by the IVUS?
Based on IVUS results, to avoid no flow, slow flow, we selected IVL to treat the proximal LAD calcification lesions.
This is a long diffuse lesion with a relatively lot of plaque burden. And also from the IVUS image, I think that gives us a very important information. One thing is that we can see there is a lot of attenuated plaque, and also the lesion length is relatively long. This patient has a mid-distal part of the LVD. There is a focal severe stenosis with a relatively small vessel caliber. So this is also a troublesome because during the rotablation, operation, if some sparkles, some small plaques, got falls off and was flushed to the distal part of the LVD, maybe there is a potential of the high risk for the slow flow and non-flow, phenomena. And also, if you pay more close attention, you may detect two relatively very large and very important bifurcation of the diagnose at the severe stenosis part.
ATM.
So, like what we have seen, and Professor Zhao is performing the IVL system. So we can see after the plaque modification using a 2.0 balloon to make the plaque modification. Now we are using an 3.0 millimeter IVL balloon, which was distributed and sent to the most severe circumferential calcification part to make this shockwave therapy for the circumferential superficial calcification. Okay, we can see that Professor Zhao has already finished the first round of the shockwave for the most severe part. We can see this part maybe at full atmosphere, the balloon doesn't open very well. I think this is the sign of the restriction of the calcification. Okay, we can see that there is a focal under expansion
6.
under the full atmosphere of the IVL. We have finished the second round of the shock wave at this current spot. Maybe one more round at the bifurcation side, because we just see that it's a little bit focal under expansion with the balloon here. And we can see that using this IVL, the patient is relatively stable with the support of the IBP system. Nowadays, with the development of the equipment and technologies, our strategies to treat this severe calcified lesion is being, different compared to
6.
the 1 or 2 decades ago. Nowadays, that we have some plaque modification balloon, and also we have the rotablation system, we have the IVL
And
system.
the first diagonal.
For my visual estimation, I think that this part is already, much better compared to the initial, seems to be much better.
Yeah.
And this kind of IVL system, we can see it's relatively very simple, very quick strategies to treat this kind of a chip patient without blocking the vessel blood flow for relatively too long time. And now we are making an angio to check the flow of the vessel. There is no sign of slow flow. And also, I think that the most severe part under the IVL, there is no severe dissection, and also the vessel diameter has been already, much better compared to what it is before. Maybe we give some vessel dilator and then check the IVUS again. And now Professor Zhao and Professor Dong is sending the IVUS catheter inside. One thing that I missed from the just the introduction of the IVUS image, we can see that the pullback speed, we have 0.5 millimeter per second, we have 1 millimeter per second, and also we have a quick scan mode using the 1.5 millimeter per second. This is the second diagonal wire joining into the main vessel, and this is the first diagonal. Okay, we already see some crack, I think, especially at, okay, here is some crack. I think after the shockwave system, we already see some superficial crack as a calcification. I think this is a good sign for the static expansion. And this is the proximal part of the LED. We are going to use the full atmosphere to make the balloon well attached to the vessel wall, so that the ultrasound wave can be well transmitted to the calcification part. We can see this part at the 9 o'clock site with the superficial calcification. There is a clear spot of the crack of the calcification out through the IVL. I do not think this is due to the balloon dilation, because we can see, although our image cannot detect the thickness of the calcification, but we can see this part using a full atmosphere is less likely to make this kind of crack. We are making the plaque modification for the stack expansion, but not tear the whole intima and also the media of the vessel. So I think that this is one good, very important teach point of how do we modify the calcification. And here as a proximal and also the distal proximal and made part of the LED. I think after the second diagonal branch, where joining into the main vessel, we can also see some crack later. For the peri procedure, we measure the length for something like 60. I think this one is still the same. The first one is something like a 3 millimeter stand, and the one as a proximal LED, I think is a 3.5. We need some further plaque modification. So yes, maybe we need to dilate the whole vessel, very precise later before the stent implantation. By the second IVUS, we found that after the IVL system, we see some very clear crack of the superficial calcification. And I think this is a good promise for the good stent expansion. So what kind of balloon did you use for the plaque modification?
105
Mhm.
balloon.
Okay, we are making the third IVUS run to check what's the plaque situation after the plaque modification using a 3.0 balloon. Okay, still we can see that there is a lot of, very diffuse lesion in the distal part of RAD. However, this is not our target lesion, because nowadays we have some good modification for the plaque stabilization. Okay, we can see some maybe very controlled intima dissection after the balloon dilation. I think this is also the good prognosis for promise for the well stent expansion. This is after the first diagonal joining inside. We can see some superficial crack of the superficial calcification after the balloon dilation. Here, we can see some well-controlled intima dissection here after this 3.0 balloon. But we can see it's controlled. It's not beyond the EEM. So this is also the good prognosis for the stent expansion. However, we notice that the plaque burden of this patient is so severe, and also some controlled well superficial calcification crack. So my suggestion is that maybe we use we use a cutting balloon or something to make further plaque modification before the stent implantation maybe 275 cutting balloon.
Yeah.
Okay.
Okay. Okay. 10. 10.
Now Professor Zhao just used a 1.0 and a 1.5 balloon to make some dilation at the ostium of
Okay.
the first and second diagonal. So our wire in the first and second diagonal is the purpose of jading wire to protect this very large, very important diagonal branch during the our procedures. So we can see that Professor Zhao just used a 2.0 balloon to make some pre-dilation before we put the IVL balloon in. So I think that CABG for this patient is a potential choice, but maybe not first recommendation for the patient. And now we can see that Professor Zhao has just finished the implantation of the first stent, and from angiography we can see it's well expanded. The first one is 3.0, and at the second IVUS run we checked the total length is around 60, and the second stent might be something like 3.5. One thing very important is that to maintain the blood flow in the two very large, very important bifurcation. Okay, well, pulling back, once again, we can see the main distal part of RAD, there is some long diffuse lesion. Like what I just indicated that I think currently we have very good medication for this kind of patient. We have PCSK9 inhibitor, we have some other very good medications for to treat this kind of a long diffuse lesion. I think we need some post-dilation and also, yes, at the most severe, plaque burden part, we need some, yes, very good post-dilation. But I think the distal edge is fine. There is no signs of dissection, no hematoma. So we need some NC balloons to make some well expanded of this first stent. Okay, so maybe we make the post-dilation first. Let's connect to the first one for something like 3 millimeter, and then we see the length. So how about 38 by 3.5?
38. Oh, okay.
Okay, because the first one is 20 something, and the total length is over 60, so maybe 38 by 3.5. And then we notice that after the first stenting, the second diagonal is still patent. I think this is a relatively good sign, because like what I just emphasized, keeping maintenance of the two very large bifurcations is of key importance in this kind of very severe, chip patient, because it's a good promise for the prognosis of the patient. And today we are using the 100% domestic software made by the Beijing company. It's called the Insight Life Tech. We can see very clear and also very sharp border of the vessel lumen, and also we can see the stent struts very clear. Okay, we make some good, NC balloon post dilation for the first stent, and then later we are going to put the second stent in. So we can see that we just use one 3.0 IVL balloons to treat this kind of lesion, and we get some good prognosis. I think the advantage of the IVUS is that it's a very high sensitivity and accuracy in detection of the calcification compared to the OCT system. And now we can see that Professor Zhao is trying to repair the first diagonal because the flow doesn't seem to be well. This is within our consideration, because before the procedure, we can see the ostium of the first diagonal is already severe focal stenosis. And in this case, we can see the second diagonal, its caliber and its length is all relatively larger. So we think that the second diagonal is more importance in this patient. And sometimes we can see that in this relatively small, short, diagnose, it's relatively difficult to maintain the blood flow. Okay, we are trying to use a small caliber balloon to make some dilation of the ostium of the first diagonal, and then we are going to try to put the second stent in. After the 2 stenting implantation, which can recover the blood flow and also is a good guarantee for the situation of the patient. Later, we check the distal part of the LVD. If the vessel diameter is around 2 millimeter and there is no large severe dissection or hematoma, maybe clinical potential usage of DEB for this kind of diffused small caliber vessel is a potential therapy strategies. Okay, we try to put the second stent to connect it with the first one. And then we check again, IVUS again to see the stent expansion. I think the current situation is fine. Like we just emphasized, the second diagonal, the caliber and also the length is relatively larger compared to the first one. So we do not worry too much about the first diagonal. Okay, from the measurement of the IVUS, the second one should be around the 3.5 millimeter stent. We need to retreat the jailed wire in the first diagonal because it's a rewired wire. We do not want to make the jailed wire in a sandwich structure because the wire doesn't seem to be a good choice within the 2 layers of the metal stands. This may make a potential jailed of the wire. Okay, I think yes, we can see that the first one might be connected already. Maybe we see from the cranial view. I think that it's already connected. Sometimes that this kind of severe calcification is hard to detect. Okay, I think it's already connected. Okay.